Hi everyone. I had some feedback to or request to go through the formulas and just explain what it means. I thought it was a great idea, so I'm going to give you a quick, well, not quick. I'm going to break down the formulas and what all of these mean on your formula sheet, so that when you're looking at them, you know exactly what you're looking at, including the symbols. All right. So class width. This is a range of data divided by number of classes. And for this one, the range is actually all the way down here, which is your minimum and maximum entries subtracted. And the number of classes, round up to the next convenient number means you're going to always round up to the next whole number if needed. All right, so class width, if needed, rounds up to the next whole number. Midpoint, lower class limit, upper class limit divided by 2. So remember, with frequency distributions in classes, you have your lower number and upper number in each row. See if I can bring up an example. Um, and I think about it. Let's see. So give me a minute. Pull up my book and show you exactly what we're talking about. Okay, here we go. So, for instance, this is 2.1 in the book if you want to go to it. This is a frequency distribution. We have our classes, which have lower number, upper number, first or second number, and then frequency. So your lower class limit is this number, upper class limit is that number. Okay. So when we're looking at the formula, that will be 0 plus 9 divided by 2. That's your midpoint. All right. So this fancy F is your class frequency. How many is in that row? And the classes mean row. Sample size is lowercase n. How many numbers do you have in your data set total? So how many pieces of data do you have total? Population mean and sample mean. These symbols, this is for population, this is for sample. Notice this is in the calculator and this isn't. So the calculator knows these are both actually calculated the same way. So the calculator just gives you this symbol. And if you are trying to find population mean, you just have to note this on your assignment. All right. X. Actually, let me go over this symbol right quick. This symbol means sum of. So whatever's behind it, you're going to add them all together. X is your data entry, or midpoint. Depends on what type of data set you have. If you have individual data, then X will be your actual data entry. So 1, 2, 3, 4, 5. If you have a frequency distribution, your midpoint is your X. All right. So that means if you have a frequency distribution, like I just showed you, but you have to calculate something, that means that the X is represented in that formula. You have to find the midpoint, which is lower plus upper divided by 2. I wish I could zoom in on this, but this is as far as it goes. Sorry about that. All right, weighted mean. So notice these have the same symbol. Weighted mean means that we have some type of frequency or category. So W is weight. And this is normally percentages. Meaning all of your data does not weigh equal. So tests normally weigh more than homework. Um, tests weigh more than quizzes. Quizzes weigh more than homework. So the weights come into play. So what does this mean? This means you have to multiply your data entry times your weight, or your midpoint times your weight, and add all those numbers together. So you have to do it in that order. You multiply first, then you add all those numbers together. With the weight, You're going to add all your weights, and that's it for this symbol. For this denominator. Okay, so this means we have to do this first, then add all the numbers we get. Mean of our frequency distribution, this is group data again. Same symbol, finding the mean, just looks a little different. F is our frequency. So we have that up there already. F is frequency. So that means we're going to have to, since it's a frequency distribution, that means we have classes. Midpoint times frequency divided by n. So n is the same as total frequency. And they also refer to it as trials. N, lowercase n is total frequency, or trials. Uppercase N is your population size. So uppercase N is your population size. Lowercase n, we deal with samples a lot. So when you see that a lot, that means your sample size. So population size, sample size. All right, population variance. Notice it has a square here. So that's population variance, that's sample variance. Those squares means we're dealing with variance. This means we're going to have to take our x value minus our mean and square. So each data entry minus your mean. So for example, if we have a mean of 3 and our data set is 1, 2, 3, 4, 5. X minus mean, or that mean, either one, means we're going to have to find the mean and then square it. So let me make it right. Since I have a sample mean, let me make sure I have my sample symbol. So that means I have to take each and every one of these first and square it. So that's 1 minus 3 plus 2 minus 3 plus 3 minus 3 plus 4 minus 3 plus 5 minus 3. So here, this means this. I have to take each x and subtract it from my mean. Okay? So that's what that means. The sum, when I put it in front of it, that's how we translate that. So x minus each mean. Summing them means we're going to add them. All right. So this formula states to get population variance and standard deviation. Pull this back on the screen. There we go. We're taking each x, subtracted from the mean, population mean, squaring it, then adding it. So you have to do it in that order. You have to find those, this in the inside squared first, and then we add those numbers afterwards. To get standard deviation, you're going to square root your fraction. Don't square root your answer, square root your fraction. Same process for variant, for sample, but your denominator is going to be n minus 1. I do recommend, if you're going to put this in the calculator and you're going to work this out by hand, find out what n minus 1 is as a number and put it in. Because if you put n minus 1 in your calculator, it may read it incorrectly. So if our n is 15, I would put 14 in my calculator for this. I would not put 15 minus 1. All right. So sample standard deviation of a frequency distribution. Notice we don't have a population standard deviation of a frequency distribution in this class. This is when we have frequency distribution, the only thing we can calculate is the sample for this class. So Z, value minus mean over standard deviation, X minus mean over standard deviation. So this is your data entry minus your mean over standard deviation. All right, so those are like basic symbols. Chapter 3 is probability. So this is the probability of event E happening. Probability of event E. So that's not P times E. Probability of event E happening. And this is a fraction. Normally our answers will have to be in decimal form, so you just set them up the way that it says and then work them out. So for P and B, and is telling you this is what you're going to do when you see and have two events. P and B, P and B. If there is dependence, then this means that event 1 happens, and then event 2 is based on what happens with event 1. So event A happens, and then event B is affected by A, so we have to adjust B. This means event A happens and event B happens. Independence, one does not have to do with another. So this A and B, let's say I'm trying to think of something just off the top of my head. So I have a bag of marbles. I pick one green marble. I don't put it back, but I pick another green marble. So now my total actually changes because I didn't put it back. That's dependent. So one depends on the other. If I have marbles and die, which is a dice, just one die, marbles and die, they have nothing to do with each other. If I put it back or not put it back, it does not affect this. So that's what the difference is for this. This means there's a change from this to this. This means if this changes, it does not affect this. Or means you're going to add and then subtract if you have something that overlaps. So A plus B, not mutually exclusive, means that there is something in common. So there could be an overlap. There's a possibility of overlap. I can have engineers, students who are engineers, women who are women, students who are women. So engineers, students who are engineers, students who are women. Any students that are women and engineers, I have to take away. So take away that probability. For here, this is mutually exclusive, meaning these two things cannot happen at the same time. So I cannot roll one die and roll a 5 and a 6 at the same time. So this is doing one event, trying to see if it happens simultaneously. This is doing more than one event and seeing if you're doing one thing and then another and then another and then another. Okay, this is multiple picks or multiple events occurring, and this is only one event. All right, so N for permutation, NPR, N is your sample size. So it says N objects, it's still your sample size. R is how many objects are you taking at that time. So N is your sample size. How many are you taking at that time? All right. Chapter 4. Chapter 4, notice we're going to deal with population mean. This is the sum of X times your probability. Remember, P is not P times X, that's P of X. X and the probability of event X happening. X and the probability of event X happening. Here, you have X minus your mean, so that one number minus your mean squared. So you're doing this for every single data entry. Same thing, every single data entry, multiply by your probability, add them all up. Has to be in this order. One other thing to note, if it has parentheses, you have to keep the parentheses. If it has parentheses, you have to keep the parentheses. Let me see if I can pull out my calculator to show you the difference. I know this is a long video, but it's good explanations. So if I have 5 minus 3 squared, I have that. But if I use it as my formula sheet tells me to use it, gives me a different answer. Okay, so if it has parentheses, keep the parentheses. Expected values. This is standard deviation of discrete random variable. So again, you're going to use those steps as is. Square root here. Just make sure you square root the right number, not the answer, but the right number. This is probability. This is binomial worked out by hand. So you know how you have binomial CDF and PDF in your calculator. But if you want to work it out by hand, this is n, your sample size, times the x that you're choosing. Remember, you have all those possible x's. X exclamation point, P to your x, so success to your x rate, Q to the complement of your x rate. All right, so this is x. This is what is left over after your success. So if you have 10 in your sample size, you're only calculating 3. This would be 7. This is what left over after you choose your success. Now this may need to be done multiple times if you have multiple probabilities to calculate. So you may have to find P0, P1, P2, P3. And you're going to have to do this every single time. Just add those numbers together. N is your success rate again. N is your sample size, but now it's called trials in binomial. Sample size, but it's called trials. N times P, N times P times Q, square root of N times P times Q. Again, note the symbols. We go back to Z in chapter 5. Calculate what Z is. Turning a Z score to an X value, because remember, all data is original data. You can convert it to a Z score to make the language the same for everyone. So if you're given a Z value, you can figure out what the original X value is. So if you convert a test score to a Z score, you can convert it back to a test score by using this formula. All right. Z ties in with table 4 as well. So yeah, Z ties in with table 4. If you need to, if you're given area. Central limit theorem, that's the condition. This is stating that you have a sampling distribution. When you have a sample, so there's a slight difference. This is population mean. This is the mean of your sampling distribution. This is population variance. This is the variance of your sampling distribution, and so forth for your standard deviation. Z-score changes when you have a sampling distribution because now you have a sample size. So we incorporate it into our standard deviation. So the actual value minus mean over standard error. Remember, standard deviation and standard error are the same thing. Standard error is the standard deviation of the sample distribution. So the symbol changes. So your equation is going to change down here. All right. Confidence interval for E. 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 That's your margin of error. And then you're going to add that to your point estimate. Point estimate is sample mean here. Point estimate is population. Um, sample proportion. Excuse me. So we have sample mean. This is sample proportion. So instead of actually having a number for the mean, we have a percentage describing what part of our sample. So 30% of our sample has this characteristic. 25 has this characteristic. So p hat is a sample proportion. What proportion means percentage. So p hat, q hat is the opposite. So this is sample proportion, and this is a success rate. And p is your success rate. Or population proportion. Population proportion. So q hat and q would be the failure rate. And put q hat right here. Remember, failure does not always mean bad. Failure just means it's not what you're looking for. If I'm looking for red M&Ms, then green M&Ms would fail. Even though green are my favorite, it would fail because it's not what we're looking for. And then Q would be your failure rate. Again, not bad, just not what we're looking for. This X, talk about X in chapter 6. This X represents the number of success. So I'll put a note up here. X for chapter 6, 7, 8. The number of successes. In proportions. So normally it represents data entry at midpoint, but for chapter 6, 7, and 8, it could represent your number of successes in proportions. So it could be a mean. If we're talking about mean, if we're talking about proportions, it could be an X. Our confidence interval for population variance. So this is chi-square. And in the video, if you have this section, remember, we note that there is no center when we're dealing with confidence intervals or population variance. There is no center, so we have to build our own endpoints with no parentheses. So these have parentheses, these don't have parentheses because there is no center. There is no perfect center. Chapter 7, Z-test for mean, T-test for mean, Z-test for proportion, chi-square test for variance, standard deviation. So our symbols are the same. Just make sure you know how to use them. This is sample mean. That's sample proportion. This is your sample size, N. This is your hypothesized mean. So this represents your claim. this represents your claim in Chapter 7. Chapter 8, dealing with two samples. So this is one sample. This is two sample if you use this in your course. To calculate Z, this is still your X minus mean divided by standard deviation. It just looks different. This is the differences of your X, differences of your mean. This will always be 0. And then your standard deviation will be calculated according to what type of test you're running and what do you have. So this is the variance over sample size, variance over sample size, square root. Okay. So this is still your standard deviation. This is still your standard deviation, but it will be different according to what type of difference you're dealing with. T-test for the difference between means. Let me just note, these, this ZT, this Z, that Z, this T, you'll get those test statistics by running the test in your calculator. This is only if you choose to work these out by formula. Okay, so this is for the formula people. Test for the difference between the means when you have dependent samples. So this is how you calculate T. This is the difference between the mean. No, this is D bar. Then the difference between the means is going to be 0 divided by your standard deviation again. So the difference between the means, the D bar, is your average, and then this is your standard deviation. Okay, so this is right here. SD, that's how you calculate SD. D is your difference, and then D bar is your difference of means. Okay. Two sample Z test for difference between mean proportions. Again, this is how you calculate your test statistic. This is going to be your P hat minus P hat minus 0, and then your standard deviation. So this is your sample proportion minus your hypothesized, were they guessing, which is going to be 0, and then your standard deviation here. I know it's a long video, but hopefully this will make sense of where all these numbers coming from. Where all these symbols coming from. R is in your calculator again, and T's in your calculator when you run your tests. But if you want to know how to find R on your own, notice all these parentheses. Put them in the parentheses, because x squared is the sum of x squareds is different from the sum of all the x's squared. All these can actually be found on 2var stat if you want to work this out by hand, instead of working them out manually. But make sure you're putting the parentheses in as you see them, especially with the squares. N minus 2, df is different, degree of freedom. N minus 2, so your sample size minus 2 now for chapter 9. R is this. R squared is this squared. Again, M, you can find all these under your 2var stat. So x times y, multiply first and add them all together. For B, this is going to be the sum of y divided by your sample size minus whatever you get here, that goes here. So find this first because it goes into your B. And then the sum of x is divided by n. I know r squared is has this formula, but you can just square this to get r squared. All right, so hopefully those who requested this formula breakdown and what they all mean, hopefully this makes sense to you. You know what? I'm going to go a little further. Table 4, extended normal distribution. Notice it has a Z here. Common ZCs are down here. If you if you don't see your ZC here, remember you can take whatever your confidence is, 1 minus your confidence level divided by 2, and find your ZC here. All right. That was the negative side. This is the positive Z side. This is your T distribution. This is DF, not N, DF. These are level of confidences because these are, you have to do plus or minus for this. These are your 1 tail, 2 tail for your tests. This tells you what your signs are going to be here. Reminds you it's a T. You're going to choose the DF that is closest to but not over the DF you see here. So if your DF is 49, your mind wants to tell you go to 50, but don't go to 50, go to 45. So if your DF is 49, you're going to choose 45. You're going to choose the one below, not above. Your chi-square distribution, you'll plug your formula in when you're giving your confidence level to find your level of significance, and then you're going to match these to find your right and left tail. Notice this is degree of freedom. It's still n minus 1. Table 11, if you choose to. Remember, these are R values. There we go. These are R values. Correlation coefficient means R values. This is the bar, meaning you have to beat this to show significance. This says N. N are your number of pairs of data. So N is your sample size, which is your total frequency, which is your trials, which can also be number of pairs of data. Exclusively for Chapter 9. All right, if you have any questions, just let me know.